Good morning, students. Today I am going to start the last chapter, that is waves, in the 11th class. Now, what is waves and what we are going to discuss? Before going to start this chapter, I want to ask whether my voice clear or not. And your response is very important. Okay. And if any question I will ask, immediately respond it, then the class will be more interesting. Right, I'm going to start the class, and first of all, write in the chat box whether my voice clear or not. Okay, students, voice and picture. Right, what is a wave? First, wave means, it is very simple, that is the disturbance. In the ninth class also you learned this one. That is the disturbance created in a medium. The disturbance created in a medium is called as the wave. The disturbance created in a medium is called as wave. Wave is the disturbance created in a medium. Okay, is called as wave. Okay, how you create the disturbance? For example, you are speaking. Now I am speaking. I am creating the disturbance in the air medium, right? While speaking, the disturbance is carried through the medium in all the directions. That is in the form of wave, right? The wave is the disturbance created in a medium, that is called as the wave. And for example, if you drop a stone into the pond of into the water, at that moment some disturbance is created in the water medium at certain place. The disturbance is carried in all the directions, you know that one. And now, what is wave motion? The disturbance you are creating, that is the wave. And the disturbance is not at rest, right? The transmission of disturbance from source to in all the directions is called as the wave motion. Transmission of disturbance, transmission of disturbance from one place to another place, from one place to another place is called as wave motion. That is called as the wave motion. Basically, how many types of waves are there? Can anyone write in the chat box what are the types of waves? Basically, the waves are two types. Waves are two types. What are they? Can anyone write in the chat box? First one is the mechanical wave. Mechanical wave. Mechanical wave means what? This wave require medium for its propagation. Require medium. Without medium, this wave never goes. Require medium for its propagation. Propagation means moving from one place to another place. For the propagation, what requires? Medium requires. These are again classified into two types. Okay, the mechanical waves are reclassified into two types: longitudinal wave and transverse wave. Okay, these are two types. First one is the longitudinal wave, and the second one is the transverse wave. Right? The waves are two types. And the next one I am going to explain. The second one. The second one is the first one is the mechanical wave, and the second one is the electromagnetic wave. Electromagnetic wave. Right? What is electromagnetic wave? Electromagnetic wave not requires medium for its propagation. Okay, right? Without medium also it can travel. We will discuss clearly in the future. Not requires medium for its propagation. Okay, this electromagnetic wave has only transverse nature. For its propagation, medium does not require. Okay, and this electromagnetic wave has transverse nature, and the example for this electromagnetic wave is, example for this is light waves are the electromagnetic waves. Okay, light waves are the electromagnetic waves. For this, medium is not required for the propagation. Longitudinal wave example is sound wave. Okay, and transverse wave example is waves in string. Waves in string. String means thread. Okay, right. We will discuss clearly now. The basically the waves are two types: mechanical wave and electromagnetic wave. If the wave, for the wave propagation, if medium is required, that is called as a mechanical wave. If medium not required, that is electromagnetic wave. Example for the electromagnetic wave is light wave. Electromagnetic wave has transverse nature, and the mechanical wave has two types, that is a longitudinal and transverse wave, that is based on the direction of vibration of particles. Okay, right. Any doubt, students? If you have any query, write in the chat box. Okay, right. Now let us continue now. I am going to erase this one and I will continue. Next one is we will discuss about the two types of waves. First one is the longitudinal wave and the second one is the transverse wave. What is longitudinal wave? Right? And this one we discussed in the ninth class also, right? Longitudinal wave means for the wave propagation, okay, this is the mechanical wave. It requires the medium for the propagation. And here in this longitudinal wave, what happens if the particles in the medium, if the particles in the medium, if the particles in the medium vibrate parallel to the vibrates parallel to the direction of propagation of wave, direction of propagation of wave. If the particles in the medium vibrate parallel to the direction of propagation of wave, then such wave is called as, then such wave is called as longitudinal wave. Okay, longitudinal wave means, okay, medium required means particles required for its propagation. Then in this medium, particles vibrate parallel to the direction of propagation of wave, right? It is a longitudinal wave. Even this definition again I will explain, don't worry. Okay, right. Then how we will go for this one? Example for this longitudinal wave is the sound wave. Sound wave is a longitudinal wave. Then what happens at here? For example, this is a speaker. This is a speaker. It producing the sound. Now let's consider this is a speaker. It can produce the sound. For example, the disturbance is created in the medium, and the air particles gains the sound energy, and they vibrate. Starts the vibrate, and the air particles vibrate like this. All the air particles goes to a side, then at some place the air particles which are just beside of this speaker gains the energy and they vibrate and goes forward like this. At some place you find the more particles are there, and at some places less particles are there, and at some places the more particles are there, the particles are in more number. At some place the less particles are there. Where the particles are more, that location is called as the compression. Where the particles are less, and that location is called as the rarefaction. Okay, and this is compression, and this is the rarefaction. This is the compression. This is rarefaction. This is compression. Okay, here what happens? The particles are, the wave is sound is traveling right side. This is the direction of propagation of wave. Direction of propagation of wave. and how the particles are vibrating. The particles are moving forward and coming backward. Their vibrational direction is parallel to the direction of propagation of wave. Okay, right? They will vibrate. The particle can vibrate at its own position and transfer the energy to the next particle. Next particle vibrate at its own location and transfer the energy to the next particle. Like this, the part in this transmission of the wave, right? A transmission of energy uh, during the propagation of wave, transmission of energy takes place, not particles, right? Okay, the particles are vibrate, their vibrational direction is parallel to the direction of propagation of wave. And we will discuss some important points regarding this. That is, in longitudinal wave, a series of compressions and rarefactions will come forms. A series of compressions and rarefactions forms in longitudinal wave. Okay, in longitudinal wave, series of compressions and rarefactions forms. One compression plus one rarefaction. One compression plus one rarefaction. By combining one compression and one rarefaction, we say that one longitudinal wave. Actually, why compression and rarefaction will forms? Because here the particles are gaining the energy and they are moving forward during the vibration. When they will move forward at some place, you will find compression, because already here particles are there. These particles during vibration also they will go right side. Okay, and then after here compression forms. After some time, what happens? This compression will disappears and it will go to here, and here rarefaction will come forms. Why? Because here the particle which is going right side and again it will come back, because the particles will vibrate at their own position only. When they will come back, then here number of particles will be reduced. Some particles which gains the energy from the previous particles and they move forward like this. Here rarefaction will forms first, where the compression forms there the rarefaction will forms in the next time, right? Compression will go forward like this, the transmission of energy will takes place. One compression plus one rarefaction is called as the one longitudinal wave. Okay, right? You see here, this is a for example, the you take the compression as this one. Here the lines are very close to each other, particles are close, and these lines are far away from each other. This we can take as the rarefaction. This is the rarefaction. Now you see one compress, this is one compression and this is one rarefaction. Okay, and one compression plus one rarefaction is called as the one wave. That wavelength is the lambda. Okay, wavelength. Wavelength means what is a wavelength? The distance between one wavelength. This is one wave, now one compression plus one rarefaction. Here the lines are close means particles are close to each other. Compression takes place. Particles are far away, lines are far away. That is a rarefaction. One compression plus one rarefaction is called as the one wave. The distance between successive compressions are rare fractions is called as transverse wave. This is called as the transverse wave. Sorry. It is longitudinal, na? Right. It is the longitudinal wave. Next, I'm going to erase this. You take the screenshot. Next, we will discuss about the transverse waves. What are the transverse waves? Which is said to be transverse wave? How the particles vibrate? In the longitudinal wave, the particles vibrating parallel to the direction of propagation of wave. But in the second type of wave, that is the transverse wave. In this transverse wave, how the particles will vibrate, right? In these particles vibrate perpendicular to the direction of propagation of wave. If the particles in the medium, if the particles in the medium vibrate perpendicular to the, if the particles in the medium vibrate perpendicular to the direction of propagation of wave, okay, direction of propagation of wave, particles in the medium vibrate perpendicular to the direction of propagation of wave, then such wave is called as, such wave is called as transverse wave. This is the transverse wave. Okay, in the transverse wave, particles vibrate perpendicular to the propagation of wave. That means example for this is, okay, ripples in water. Okay, in the water the waves are there like this, it will pumps. For example, this is water. If you stop any stone it here, then the, like this, the disturbance will be carried in all the directions, right? In the part, if these particles are moves up and down, right, particles moves up and down. Example is waves in strings, we can say. Waves in strings or waves on surface of water. You see here how the transverse wave will forms. For example, this is a rigid support, and here we are taking one string, and once you can vibrate perpendicular to its length, then some disturbance is created it here. That one crust created it here. This is called as the crust, and then that will be carried in forward direction like this, right? What happening it here? This is the direction of propagation of wave. This is the direction of propagation of wave. DPW means direction of propagation of wave. But how the particles are going? The string is going up, right? Next time string goes down. That means what happening it here? The particles are going up and down. The particles are going up and down. But this is the vibration, right? The vibration is up and down. But how the wave is going? The wave is going forward, right? Here we are creating the disturbance. This is the direction of propagation of wave. Now the particles are vibrating in a direction that is perpendicular to the direction of propagation of wave. Then such wave is called as transverse wave. And now some points regarding this transverse wave I am going to give. In this, there are some ups are forming. These ups are called as the crests and the downs are called as the troughs. In this, a series of crests and troughs forms. Right, in transverse wave, a series of a series of crests and troughs forms in transverse wave. Right, what happening? A series of crests and troughs forms in the transverse wave. Okay, right. Next one is, if you combine one crest along with the one trough, if one crest and one trough is combined, then we will get as one transverse wave. One transverse wave. Okay, for example, this is one crest and this is one trough. If you combine both of them, and this is called as the one transverse wave. One transverse wave, one wave, this one. And such wavelength, such wave, this is we are taking that as wave, its length is the called as wavelength. This is the wavelength. And the next one is I'm going to tell that the what is the wavelength. Wavelength definition also we can write here. One crest starting at here. Okay, next crest starts at here. The distance between these two successive crests is also called as the wavelength, right? The distance between successive crests or troughs is also called as transverse wave. The distance between successive crests or troughs is called as transverse wave. Okay, students, understood what is transverse wave, right? Any doubt, students? If you have any query, write in the chat box. Okay, clear, students? Is it clear? Any doubt till now? Write in chat box. Otherwise, we will continue the class. Next, clearly appearing na? Right. Good, baby Mato. Right. I'm going to erase and I will continue. We will start the actual topic of to 11th class now only, because till now whatever that we discussed, these are the basics. That basics we learn in the ninth class only, right now. Okay, now let us start the next most important topic, that is the progressive wave equation. What is progressive wave equation? Progressive wave equation, right? Progressive wave equation I am going to write. This is very important. Based on this, you will get the problem, right? Progressive wave equation means, for example, this is a coordinate system. This is x-axis and this is the y-axis. Now I am taking one wave, right? The wave starts from the origin and the wave is traveling like this. Okay, wave is traveling like this. And now here at a position x, for example, the wave traveled x distance after time t. This is the position, that is at x distance it is. Now at this position, the displacement of the particle is going up here. The displacement we can consider as the y. Okay, and here the particles are going up and down. For example, you find out this how whether it will go up and down. If you want to know practically, then you drop a stone in the water. Right? You drop a stone in the water. Okay, the ripples will start and goes. One leaf you can keep it. You drop it here. You feel that the water is flowing like this, but the water is not flowing, right? Here just the disturbance, the water molecules are going up and down. It here water molecules are going up and down. You see here, if you place one leaf at here, the leaf goes up and down, but not goes forward, right? By this we can understood that if you, for example, this is once again I will repeat, this is a pond of water. You drop a stone into this, here disturbance created, that will be travel like this, and you feel that the water particles are going. But if you drop any leaf at here, that leaf goes up and down but never goes forward. By that we can say that only energy is carried in forward direction, but not particle. If the particle below leaf, if it will goes forward, the leaf also should go forward, but it is not happens. That means the particles vibrate in their own position and transport the energy to the next particles. Next particle also vibrate in their own position and transfer the energy to the next particles. Like this, the energy only carried in forward direction, not Once wait, I will redraw this diagram. This is the y-axis and this is the x-axis. Okay. Now the part wave starts at the origin and it is traveling like this. And the wave travels some distance, that is x distance traveled at this location. Then for this it travels some time. Then this location we take as the x comma t. And at this location the particle takes some displacement. That displacement we can take as the y. Y is the displacement of the particle. After some time this particle goes down and like this it is vibrating. This is the direction of propagation of wave. This is the direction of propagation of wave. But the particles are going up and down. कल का पूजा वाला में प्रसाद वितरण में आपका नाम दिया हुआ है progressive wave equation. Okay, progressive wave equation. Now this wave is going forward direction. Progressive wave equation means here the particles are moving up and down. They are in oscillatory motion. Okay, remember it. The water particles are, the water wave is going like this. Then the water particles are goes up and down. There they are in SHM. They are in SHM. Progressive wave equation is nothing but displacement of particle. Displacement of particle. Displacement of particle at position x after time t. That displacement I want. That we write as y is equal to a sine we write as kx minus omega t. Okay, or sometimes we may write the plus omega t also. Okay, this is the y is equal to a sine kx minus omega t. We write this is y is what at here, displacement of particle at position x after time t is y. The formula for the y is equal to a sine kx minus omega t. Why we wrote like this sign? Because this particle is in SHM. In SHM equation, in the last class we derived SHM equation is y is equal to a sine omega t. The displacement equation in SHM. In SHM, simple harmonic motion displacement equation we write as y is equal to a sine omega t plus phi or a cos omega t plus phi. Sinusoidally or cos you will get right now. That's where we wrote like this. I will explain the terms in that. Okay, don't worry. And equation 1 indicates progressive wave. That above equation is called as the progressive wave equation. Progressive wave equation traveling along positive x-axis. This is the equation for the progressive wave traveling along positive x-axis. Okay. Next equation we write y is equal to displacement of particle. We write as y is equal to a sine kx plus omega t. This equation 2 indicates that it is also progressive wave equation. Wave equation is nothing but a particle displacement equation. The particle is in SHM. In SHM we write in function of sine or cos. A is the amplitude we discussed already, right? Equation 2 is the progressive wave equation traveling along negative x-axis. Traveling along negative x-axis. Okay, now general equation of progressive wave what we can write. If you combine both of them, you will get the general equation of progressive wave? The general equation of progressive wave is, progressive wave means what? A wave which starts at a point and always moves forward. Progress means moving forward. Such wave is called as the progressive wave. The general equation is minus a kx minus r plus omega t. This is the progressive wave equation. Understood? This minus for the positive, if the wave moving in positive x-axis along the positive x-axis, minus we write if the wave moves along the negative x-axis. Okay, we write the plus. Minus for positive x-axis, wave traveling along the positive x-axis, plus for wave traveling along negative x-axis. Okay, students, understood everything? Now we discussed about the terms in this. Okay, we will discuss the terms which are present in the progressive wave equation. What are the terms which are present in the progressive wave equation? Let us see here clearly, and if you have any query, write in the chat box. Right. Okay, students, do it at here. Do it here. Look at here, where A is the amplitude of progressive wave. What is A here? Amplitude. Amplitude of progressive wave. What is amplitude actually? I will explain. Okay. And K is called as the propagation constant. What is K? Propagation constant. Propagation constant. And K has some formula, you remember, that is the 2 pi by lambda. This propagation constant also said to be wave number, angular wave number we can say. Okay, and where lambda is the wavelength, lambda is the wavelength. In the exam they will ask, right, to find out the wavelength or something by giving the equation. K completed. X means you know already, position of the particle. Okay, x is the distance traveled by the wave. Or we can also say that position of particle. T is the time, and omega is the angular frequency of wave, angular frequency of wave. How to write the omega formula? Omega formula we have 2 pi by capital T, where T is the time period. T is the time period. And this bracket complete angle we can have, angle also has some name. This kx minus omega t is called as the phase. I explained every term in this. Okay, y is what at here? Displacement of particle. Okay, displacement of particle. Okay, right. This is the terms which are present in the progressive wave equation. Okay, right. Now let us discuss the few important definitions in the progressive wave equation. In the exam they will ask, they will give such equation: y is equal to something like this, y is equal to 2 sine 300 pi x minus 200 t, like this they will give. They will ask, this is the wave equation, then they will ask to find out the wave amplitude, wavelength, and propagation constant, angular frequency, time period. Like that they may ask the many things. You should compare with the general equation. A is equal to 2, x multiplier is k, x multiplier is 300 pi, like that. T multiplier is omega, omega is 200. By that, by using omega you find out the t, by using t you may find out the frequency, right? Like this we use the progressive wave equation. Okay, I'm going to erase this. Next I will continue. I will give the few important definitions, right, that we are learning in the progressive wave. The first one is the amplitude. What is amplitude and how to define the amplitude of wave? Amplitude of wave is nothing but in the wave, amplitude is the maximum displacement of particle from the main position. The maximum displacement of particle. Maximum displacement of particle from main position is called as the amplitude. You know very well about this one, right? Now, amplitude is denoted with A. If this is the wave, if this is a wave, and different particles have the different displacements, but here one of the particle have the highest displacement, and that is called as the amplitude. This is called as amplitude. Okay, students, understood now? This is amplitude, right? If you take the this is a wave, if you take different particles, this particle have this much displacement, this particle have this much displacement, this particle have this much, this is the highest displacement, that is called as the amplitude. Maximum displacement of particle from the main position is called as the what? Amplitude. Amplitude is denoted with capital A. This is denoted with capital A. Understood, students? And the next one we will go for the time period. Time period means what? It was very simple definition. The time period means time taken to produce one wave. Time to produce one wave. How much time takes to produce the one wave? That time is called as the time period. For example, if you take the time on x-axis it here, okay, this is the capital T time takes to complete the one wave, right? And the time to produce one wave is called as time period. Time to complete one oscillation is called as the time period. Okay, the definition also we know, time required to complete the one oscillation. This time and that time is same. Okay, time required to complete one oscillation also we can say. Complete one oscillation, particle will oscillates, or time to produce one wave. One wave, how much time takes to produce is called as time period. This time period formula is 2 pi by omega, where omega is the angular displacement, angular velocity, or the angular frequency, angular velocity or angular frequency. Now, what is the general frequency definition? Next one is the frequency means what? Frequency. Frequency of the wave. Certain wave frequency means the number of waves per second or the number of oscillations per second. In 1 second, how many waves are produced? Number of waves per second or number of oscillations per second. Number of oscillations per second. In 1 second, how many oscillations it is taking? That is called as frequency. Okay, students. This is called as the frequency. Next, we know that the frequency is the reciprocal of time period, right? This we can also write as omega by 2 pi. By this frequency formula we got it here. From this angular velocity formula also we write angular frequency formula. Is 2 pi by t we can write, or into 2 pi into nu also we can write. Remember, this is the angular frequency. Okay, right? And the next one is the some important definition we are discussing now here. What is phase? Phase means what? The definition already I said the phase, right? Phase is a physical quantity. A physical quantity, a physical quantity which describes which describes position and position and direction of vibration of particle is called as phase. This is the definition of the phase. Okay, for example, the wave is traveling like this. This is a wave. The wave is traveling in forward direction. If the wave is traveling in forward direction, its phase will be increases. For example, here there is no phase. If here the phase is 0, and here it will become pi phase, because here upward direction vibrating means here it will goes downward, and here it is again goes upward, again pi increases 2 pi, here it is 3 pi, here it is 4 pi. Why? Here upward direction vibration, here it will become the downward, next here it will become upward, here it will become downward, here it will again become upward. That means after every crest or trough 180 degrees it increase 0, 180 to 360, 360 plus 180, right, like that. Angle is increasing it here, it up become down 180 degree, down become up again our 180, 180 plus 180 360, like that, right? And now this phi is called as the phase, but there is a formula is there for the phase. The phase formula is kx minus phase of certain particle. For example, at this particle, if you want to know the phase of a particle at position x after time t is, there is one formula is there for the phase, that is kx minus omega t plus phi. Okay, this is angle is said to be phase. You know everything in this, right? And here in the phase is nothing but angle at here. This angle shows, based on the angle we can tell the position of the particle, and based on the angle, this is the angle, okay, phase of certain particle we can find out. This is a phase is a angle, the phase formula is this one. And now what is phi in this? Kx minus omega t we know. Phi means what? Okay, phi is the initial phase. Initial phase. This is also said to be epoch. EPOCH. We can say. Now, at x is equal to 0 and t equal to 0, phase is called as initial phase. Okay, phase is called as initial phase. Find the phase at x equal to 0 and t equal to 0. Then we will get the initial phase. What you will get here? You write x0 t0, you will get phase as only phi. This phi is called as the initial phase, starting phase. If initial phase is not there, then phase formula will become only kx minus omega t. And let us go for the next one. The more concept I am going to give, right? Okay, I will erase these quantities. Till now, how many we discussed? Fourth one is completed. Now let us go for the next one. We discussed the amplitude, time period, frequency, phase. right? Phase is a angle. Now, students, any doubt, write in the chat box. Is it clear till now? Is it clear? Any query? If you have any query, write in the chat box. Don't hesitate to write in the chat box. Okay, students? Right, let us start. Now, what I am going to explain? Right, I am going to explain one thing. Next point, the fifth one I am going to tell. That is the wavelength. Wavelength already we know. Na? Wavelength. What is wavelength? Wavelength is denoted with the lambda. The distance between the successive crests or troughs is called as the wavelength. Is it right? The distance wavelength is nothing but one wavelength. The distance between successive crests or successive troughs is called as wavelength. There is a formula is there for the wavelength. We can also define the wavelength in another format also. There is another method is there to define also. The distance between the two points which are in the same phase. For example, here this angle is like this. It is the wave is there. Here it is vibrating upward. Zero phase we can take. Here it is vibrating upward. We take the phase as 2 pi. Why? Up, 0, down, pi, up, 2 pi. These 2 points are at the same phase. 0 degree, 2 pi degree same. Right? 360 equal to 0 again. That's why the distance between these two points are said to be having the same phase. These A and this point and this point. The distance between these 2 points is called as the wavelength. Simply also we can say one crest and one trough is a one wave. Its length is the wavelength. Is it right? And the next one is the last one, that is wave velocity. Wave velocity. What is wave velocity? Wave velocity is the V. There is formula is there for the wave velocity. Wave velocity means the distance traveled per unit time. Is it right? The distance by time. Distance traveled by the wave per unit time is called as wave velocity. That is called as the wave velocity. What is wave velocity? Wave velocity we write like this. That is the distance traveled by time. How much distance traveled and how much time takes. And for that, what we have to do it? Here you see here, wave travel lambda distance. This is a wave we can consider. This is a wave. Wave is traveling forward direction like this. The wave is going. Right here, the wave travels some distance. This is completed one wave up to here. This is 0 time. Here up to this point, capital T time it will take. In this capital T time, how much distance it is traveled? The wave traveled lambda distance, right? Distance traveled by the wave is lambda and time is capital T. Because why it is capital T? Because in one wave, for one wave, the time for the one wave, the distance is lambda and the time is capital T. Lambda by capital T we write. Is it right? And now, but the lambda by wave velocity is the v. V is equal, we have the lambda by t. But we write here this as 1 by t into v. But 1 by t into lambda we write. But what is 1 by t? 1 by t is the new reciprocal of time period is called as the frequency. We write v is equal to wave velocity is the v. Its formula is frequency into wavelength. We write that wave velocity is equal to frequency into wave velocity. To find out the wave velocity, we have formula, that is the frequency into wavelength. Frequency into wavelength. This is wave velocity. Next one I am going to explain, that is, there is, for certain wave, the phase of a certain particle is constant. Okay, for certain particle in wave, phase is a constant. Phase is a constant. That is not required. This is not required actually. Directly I will write. I want to write the wave formula in terms of omega and k. You know, you convert this nu into omega is equal to, we know as 2 pi nu. From that nu we write as omega by 2 pi, and k is equal to, we know as propagation constant 2 pi by lambda. From this lambda is equal to, we write as 2 pi by k. This you substitute in above equation, then wave velocity formula nu is omega by 2 pi, k, lambda is 2 pi by k, and 2 pi gets cancelled. The wave velocity formula is omega by k also. Omega by k, right? This is about some basic concepts regarding the wave. Next I am going to erase this. Next topic is the velocity of transverse wave. How to find out the velocity of transverse wave? Next topic is the velocity of transverse wave. Velocity of transverse wave. How to find out the velocity of transverse wave? For example, we are taking that this is a table, and here one pulley is there, pulley this one, and here one nail we are fixing, digit support this one, and for this we are hanging one nail, we are attaching it here, and thus throw this. Here we are hanging some weight pan at here. This is a weight pan. Some weight we are hanging it here. This weight we can take as the capital Mg. How much weight we are applying it here, that much tension is created in this. Tension means a stretching force. Tension is there in this stretching force. Okay, right. And if you will pluck this one, perpendicular to its length, then some wave will be produced in this. Right, that wave speed formula I want. Then for this, then velocity of wave velocity of transverse wave in string, velocity of transverse wave in string, that depends upon some factors. That is, V is equal to formula is under root T by nu. This is the velocity of transverse wave formula. What is T in this? T is the tension in the string. Tension in string. Who is creating the tension? Tension means a stretching force. Here, this load tries to stretch this wire. That stretching force is called as the tension. Tension is equal to weight of load. Okay, weight of load. What is tension means stretching force, and nu means linear density of wire, linear density of string, linear density of string. What is linear density? Linear density means mass per unit length. Mass per unit length is called as linear density. Linear density means mass of wire by mass of string by length of string. That is a linear density. Linear means length. Okay, length of string. Then what is mass of string? That is m. Length of string is L. You multiply with A and divide with A. Then mass into area, denominator length into area will become the volume into cross section you will get. Mass by volume we will get as the density. Density into area. Rho is the density of string. Density of string. A is the area of cross section. Area of cross section. Okay. Now we will get like this. V is equal to under root T by nu. Nu we write as rho A. Okay. Nu is the mass of the string by length of the string. That is a linear density. Okay, students, understood everything clear? This is about velocity of transverse wave. And one question I am asking to you, that show that V is equal under root T by nu is dimensionally correct. Show that V is equal to under root T by nu is dimensionally correct. This is one question. Show that V means what? Velocity of transverse wave. Show that V is equal to under root T by nu is dimensionally correct. In this nu means linear density. Okay, that we have to show. Then further purpose solution, let us start. What I am doing it here, I am going to show that V is equal to root 2 by nu is dimensionally correct. Then in this LHS is what here? V is there. What is V? Velocity is the displacement by time, right? That is L by T. Elastic dimension formula is LT inverse, and on the RHS side there is a under root T by nu is there. Under root T by nu. What is the T dimensional formula? T is the force, tension. Tension is nothing but force. Force dimension formula, mass into acceleration. MLT power minus 2. What is nu? Nu is the linear density. Is it right? Nu is the linear density. Linear density means mass by length. Mass by length. Mass is m, length is L. We write as ml inverse, and tension is the force. Force is the mass into acceleration. Mass is m. Acceleration we write as velocity by time. Acceleration LT power minus 2. These two you substitute in above equation. ml inverse. Cancel. L goes to the numerator. L square, L power minus 1 L. L square T power minus 2. This we can write like this. LT power minus 1 whole square. Square root will cancel. Finally, we will get the LT inverse. Therefore, LHS is equal to RHS. Right now, that means V is equal to under root T by nu is dimensionally correct. Okay, students, any query? Is it clear or not? Is it clear? Not responding.